Welcome to this video on iodine-thiosulfate redox titrations. Our first learning objective here is to know what these titrations are used for, and the purpose of an iodine-thiosulfate redox titration is to analyse oxidizing agents. We're thinking there about such as iron 3+ we use today, copper 2+ will work, halogens, things like chlorine, these are going to work as well, and they're going to be reduced during the procedure. So if you're thinking of using an iodine-thiosulfate titration, you can only use this sort of procedure to analyse the properties of oxidizing agents, which are going to be actually reduced during the titration procedure. And this stands in contrast to manganate type titrations, which are actually used to analyse reducing agents and nicely complement them. So we're looking at analysing, and by that we mean things like finding the concentration. You might be able to find the mass of that substance, and you can use that to find things like the formula mass, and hence the formula, percentage purity, that type of thing. But this is the basic idea of analysing these oxidizing agents. So in this first video we've got some aqueous iodine in this conical flask at the bottom, sodium thiosulfate in the burette. I'm going to add the sodium thiosulfate from the burette and just give a swirl, and you can see that the colour is gradually fading. See now it's going, you can see it's going a yellow colour, and eventually we're completely colourless. Well, you've seen on the video this reaction taking place. Let's try and understand what just happened there. The iodine in this process is being reduced. So iodine is gaining 2 electrons to become iodide. Meanwhile, the thiosulfate, which was in the burette, is being oxidized as it reacts with the iodine. It's losing a couple of electrons, and actually you can see this is the thiosulfate. Over on this side it's a 2 negative ion, very similar to sulfate, but just with one of the sulfurs, a sulfur replacing one of the oxygens. And this actually forms this ion here, S4062-, or tetrathionate, by forming what's called a disulfide bond here, and that required a loss of 2 electrons. So if we put these together, we get the overall equation for this reaction, which is shown here. And the key point here is that the iodine has this brown colour. And so as the titration proceeds and you add more and more thiosulfate, nothing else here, these are all colourless. All these other substances are colourless, and so gradually the iodine brown colour becomes a yellow colour as you add more thiosulfate, and eventually it goes completely colourless. In this next demonstration we've got still sodium thiosulfate in the burette and aqueous iodine in the conical flask beneath. Now the previous one, where we added the thiosulfate directly to the iodine, gave a gradual loss of the brown colour. That's not very good for titration. We want a sharp colour change. So we're going to use starch as an indicator. We don't want to add that initially because it will bind too strongly to the iodine and give us inaccurate results. So what we do is we add some of the thiosulfate until the colour has faded. So I'm just going to be cautious about how I add that. You can see the colour is fading. It's still a brownish colour. We're aiming for a sort of pale straw colour. So a sort of pale yellow colour. I'm almost there. I just don't want to overshoot this. It's very tempting to add this too quickly and then we overshoot. There's something close to this. Yeah, I think just another drop or 2 more. There we go. So now we're ready for just 1 more drop. Yeah, there we are, ready to add our starch. Now if we've overshot, the starch won't go a blue-black colour. We had about 1 centimetre cubed of starch from a pipette, and we've still got plenty of iodine there. You can see, just give that a swirl. So now what I'm going to do is just set the burette to add this dropwise. Now if you were doing this in real titration mode, you'd add 1 drop at a time, but I want to just show you what the colour change looks like by adding dropwise. You can see still the blue-black colour,
and you should be able to see, just in one drop, it's gone to completely colourless.
Now in the last video you've seen that we can actually use starch as an indicator. So let's just explain exactly how that's working. So overall exactly the same reaction. And we're adding sodium thiosulfate to the iodine. It removes the iodine and turns the solution a yellow colour. Now because we want a nice sharp endpoint for the titration, we add some starch. And so when we add starch here, what happens is that the starch binds to the iodine. It's actually quite a complicated procedure involving some strange species that we're not going to go into here. But if we add our starch here, it binds to the iodine. Now when we carry on adding more thiosulfate, the iodine does unbind from the starch and it will react with thiosulfate. So the I2 continues to react. And that unbinding is less efficient if you've got higher concentrations of iodine, and so that's why we tend to only add starch near the end. But the iodine continues to react with the thiosulfate ions when more of them are added, and eventually, even though at low concentrations starch can detect the iodine, when the iodine has all reacted with the thiosulfate, the starch, which is still in there, doesn't go black anymore because it now has no iodine in order to bind to. So that's the reason. And the beautiful thing is, because starch binds so tightly to iodine and produces such an intense colour, you can get this incredibly sharp colour change just with one drop of thiosulfate to remove that last amount of iodine. Now the great thing about this, and from the point of view of a titration, is that if we start off with 1 mole of iodine here, then let's say when we've added no moles of thiosulfate, it's going to be completely brown. When we've added some number of moles of thiosulfate, it's going to be a pale yellow colour. But we know that the minute that this starch turns colourless, we have no iodine left. We know that we have exactly, at this point here, we know that we have exactly 2 moles of thiosulfate added. And the reason we know that is because there is a 1:2 ratio in this equation. 1 iodine reacts with 2 thiosulfate ions. So 1 mole of iodine here is going to react with 2 moles of thiosulfate. And that's the basis for iodine-thiosulfate titrations.
So that second titration with starch was excellent to work out the concentration of iodine. But what we can do to broaden the applicability is to actually generate a stoichiometric quantity of iodine from another chemical. And in this case we've got Fe3+, which we can conveniently analyse the concentration of by first reducing it to iodine. So if we add some potassium iodide, it doesn't matter exactly how much, you just need to use an excess. You can see that we've got a nice brown iodine solution. So if I just lower the burette now, we're ready to titrate this. We're going to add it fairly slowly because I don't want to overshoot that end point. Once we get to the pale straw colour, we're going to add the starch. Speed up a little, but don't want to overshoot. Just adding little drops. Okay. We're ready, I think, for starch. That pale straw colour. About a milliliter, a centimetre cubed of starch. And we get it going, the characteristic blue-black colour of that starch iodine complex. So now we can proceed towards the endpoint dropwise with swirling. We're very, very close now. You can see the colour fading. You see, I think it could just be one more drop. There we go.
So let's summarise the 2-step procedure for analysing oxidising agents. So step 1, we're going to produce iodine by the oxidation of iodide. And remember, this I2 is the brown colour that we get here. Second step, we're going to react the iodine produced with thiosulfate using a starch indicator. So this is the reaction that goes on. Gradual fading of the colour, as we've seen before, We add starch and it goes blue-black. We carry on adding thiosulfate until all that iodine's gone, at which point the solution turns colourless. Now, why is this actually useful? Well, we talked on the previous slide about the fact that 2 moles of thiosulfate react with 1 mole of iodine. Now that iodine that the thiosulfate reacts with in this step is exactly the same 1 mole of iodine, or even if this balancing number were different, it doesn't matter. The key point here is that this iodine acts as a sort of link between the two, because the iodine that was produced in step 1 is the same iodine that is going to be reacted in step 2. And so if we know how much thio we've used, we know how much iodine, and that means we know how much iodine reacted here. And if we know that the number of moles of iodine reacting here, we can work back to the number of moles of Fe3+. And once we've got the number of moles, we can calculate anything we like.